All right, I'd like to demonstrate for you what a for loop is, and I'm going to compare it to the while loop, and hopefully we can see what the differences are and when you'll use one and when you would use another. First of all, when we talk about, we've been doing looping, right? We've been doing what we called a while loop, and I'm using Scratch to hopefully give you a familiarity to demonstrate these concepts. And in Scratch, nothing fancy, I've just set up this loop in which I will have this cat meow until the counter is greater than 3. And so this is similar to things that we've been doing already. So I have to, before we start our loop, we have to set our counter equal to 0. So this is my variable. And I'm saying while, and in our language we use while, but Scratch is saying repeat until counter is greater than 3. So we're going to stay in this loop while counter is, and what we're essentially saying is while counter is less than 3, then to run this particular block of code. And what we're doing here in the code is we're going to play the meow sound because that's not irritating enough. I'm going to demonstrate the variable, so we'll see the variable counter change each loop. And in each loop, we're going to increment that counter variable by 1. And so that way we don't get into that infinite loop that we talked about last week. And so each round, the counter is going to be incremented by 1 until finally, after it loops enough times, counter is going to be greater than 3 and this loop will end. And so if I play that, I'm sure we'll see, now watch the counter here. We'll see the counter change, 3, 4. And so at the end, counter was greater than 3 and the loop stopped running. We've been doing that. We've been doing that with our while loop. And so let's talk about what a for loop is then. So let me find, let's see, where is our for loop repeat here? Okay. So unlike a while loop, we continue in the loop, but inside the while loop, we set some kind of condition. We do something to create our condition to be false so that we exit the loop, right? So, or true, whichever your situation is. In other words, in this particular loop, we set our condition to run as long as counter was less than 3. Once it became greater than 3, then the loop stopped. So that was the way we controlled how many times this loop ran. And it could be 1 time, it could be, in this case it was 3, but we've also been setting a flag, haven't we? We've been saying, do you want to play again? Do you want to play again? So a while loop will run, it could run a specified period of time like we did here, or it could run an unspecified period of time. In other words, as many times as the user wants to play again. So a for loop, F-O-R, for loop is what we're going to be working on next. And a for loop is a predetermined amount of iterations. In other words, we already know that we're definitely going to run 3 times. It's not going to be 1, it's not going to be 5. We know that we're going to run a specific amount of time. For example, we might want to run, if we know that we're going to do something every day of the week, we know that there's 7 days in the week, and so we know for sure that we're only going to run 7 times. So we use a for loop when we know for sure how many times we want to run. And so the idea behind a for loop then is, let's see, we'll have it play the sound. So we'll definitely play the sound 3 times. I don't need to change the counter because there is no counter. It's just automatically going to run 3 times. So I don't need to, I can show you the counters changing. Oh, I guess there's not going to be a counter. It's just going to run 3 times. So we don't need a counter. We don't need to increment a counter. It's already set up to be predetermined at that amount of time. So let's just run that. And so let's make sure we still run repeat 3 times. Let's see if he meows 3 times. Perfect. So a for loop then is a specified amount of iterations. We know for sure how many we need, so we're not going to get stuck in an infinite loop because we're determining ahead of time how many iterations we're going to run. Versus the while loop, we could run maybe a predetermined amount of times or maybe an unpredetermined amount of times, and something inside the loop will cause us to stop looping. So let's go right into some Python code and see how we do this in Python. Okay, so now we're in our Python idle editor, and I'm just going to show you some examples, hopefully give you some visuals of how the for loop works will help make things look a little bit clearer. So in my Python file, my .py file, I've annotated, I've given you comments creating the for loop. So let's look at examples of how to create a for loop. So we're going to start with the word for, and I'm going to just type this out for the moment. I in range, and I'm going to say 10. That looks really weird at the moment, but oops, I in range, that needs a parenthesis. It's going to make sense hopefully as we progress here. So be patient with the process and let's see how we do. Okay, so when we create a for loop, there's usually, and you'll usually see it's going to be the variable name I. That's just something that's kind of common with programmers. So usually a for loop uses a variable name I. Don't know, maybe that stands for iterations, I don't know. But for I means that I is going to automatically be our counter. So similar to what we just did in Scratch where we had a variable name counter, for already kind of sets itself up to say, I'm going to use this variable name I. You can use whatever name you want, but this is pretty common. And then in range simply means generate it generate 10 loops. So iterate 10 times, do that loop 10 times, and each time you're in the loop, print out I. In other words, I is automatically going to get incremented every time it goes through this loop. And I didn't have to write that much code to make it happen. Let's see what happens. Let's just see it run. So you can see that, here's my output. It automatically generated I, automatically incremented, and the code ran 10 times. The iteration ran 10 times. So for 10 times, the first time I was 0, and I printed out 0. The second time it looped, I was automatically incremented. I didn't have to increment it. It automatically was. And the second time I was 1, and all the way down to 9. So although in your head you might see, but you said range 10, well, the computer generated, the for loop generated 10 loops. But unlike you and I, computers start counting at 0. So I was automatically started at 0, and it printed 10 iterations. So there's 10 iterations here, but it ended in 9. So 10 numbers were generated, 0 through 9. So that is a for loop in its very simplest form, but I wanted to also print out the I so you could see how I was automatically incrementing inside that loop. So you say to yourself, well, I don't always want to generate a number between 0 and, or maybe I want I to be different things, but I still want it. I don't really understand. Let's just try another example. So I'm going to comment out this particular block, and we're going to do another example. If you send for I in range, this time I'm going to put 2 numbers into this parenthesis. I'm going to put a 1, 11. And whatever numbers you put in here are your starting and ending numbers, except this number is not inclusive. In other words, this is going to generate, this will iterate 10 times. The first time it runs through, this time I is going to be 1 instead of 0. And it'll generate 10 numbers, so it'll generate 1 to 10. It doesn't include this last number that we wrote in here. So if I write print I and run that, we should see, let's see what our output is. Run module. And you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this time I initialized itself or set itself to the value of 1. The first time it went into the iteration, the first time it went into the loop, it was 1. And it generated 10 iterations, 10 loops, ending in I being equivalent to 10. So if you use this format and you put in 2 numbers, this will be your starting number, what I will begin with, and this is what it'll end at, but not include. So the last number is non-inclusive. So let's look at another example. I'm going to comment out this part. Okay. And let's look at another possibility for the for loop. Now this time I'm going to do for, and you see a pattern here for I in range. This time I'm going to go 0, 21, and 2. So now if I send 3 numbers over, what I'm asking it to do is start at 0. It's always your starter. It's similar to what we did up here. Run until, but not including, I equals 21. So similar to what we did up here. But this time, instead of adding just 1 to I each time, add 2. So we call this your step or your increment. So how many, this should be a colon, how many, and this time instead of I being 1, it's going to start at 0, and then it'll add 2 each time. In other words, let's just see it run. I think sometimes the visual is a little bit clearer than my trying to explain it. So this time we iterated, I kept adding 1 to itself. Let's see what happens now. Now when we print it out, you can see that the first time I was 0, it incremented itself by 2, because we said step or increment by 2, and so we see 2s, 4s, 6s, etc. being printed out. So we have really a loop that's doing 2 things. It runs a specified amount of times, but it also has this little variable that we can use to either keep track of a counter, tells us how many times we were in, or we can use it, well, let's just do as an example. Let's just, now that we see how it works, let's make it useful. Let's put it into a program. So I have this problem called bug collector, and I'm going to copy it in, and let's take a moment to read it. This is what we're going to try and accomplish. So we're going to write a program, and what I highly suggest you do is stop this video and pseudocode this problem so you see it on paper and you do the logic before we actually end up writing the code. But I'm just going to jump into the code. Hopefully you've taken an opportunity to pause and look at this problem before continuing, because it'll mean more. But the idea here is that a bug collector would like to keep track of how many bugs he collects. Of course, it's a boy collecting bugs. I know, I'm just saying, bugs, but that's okay. I guess girls can collect bugs too, and there's nothing wrong with that. Anyway, so we write a program where he can enter how many bugs he collects each day of the week, or she. Print out how many bugs were collected during the week and the average number of bugs collected each day. So if you pseudo-coded this out, and I hope you did, you're probably getting to the idea, well, we have 7 is going to be, we definitely know that we're going to use 7, that there's going to be 7 iterations. There's no denying how many times we need to loop through this code. Each day of the week, we need to collect the amount of bugs that were collected. We need to enter that. And I'm sure you're seeing that we're going to have to keep an accumulator. Somehow we're going to keep a variable that is keeping track of or adding to itself all the bugs that were collected. And then we need to print out an average. So we're going to print out the total amount of bugs that were collected divided by 7, because that's going to give us an average. So I'm just going to jump into the code and start plugging things in. So I'm going to create, there should be 2 variables that were created. And what I'm keeping track of here is the fact that we have, maybe this is our total bugs collected. So this is the variable that's keeping track of all the bugs we've collected for the entire week. And this is the number of bugs that was just collected on that one iteration, that one day. So each day we're going to get this value from the user, and then we'll add it to our total to keep a running total. Okay, so let's see how that works. Well, obviously I'm setting you up to do a for loop. So there was our syntax was for, we generally use the letter I for our variable in range, and we know that we're going to loop through this 7 times. We know 7 times we need to collect the amount of bugs. So, or bugs were collected, and we need to put it into our running total. So the first thing I'll do is I'm going to ask the user how many bugs were collected today. So in a loop each day, the repeating code is bugs today is equal to. Now remember, first I'm going to put my input, how many bugs. I'm just going to abbreviate this because I don't have a lot of real estate here. So the idea here is how many bugs were collected. Now remember that when I use the input to get information from my user, I am receiving a data type of a string. That's just what happens with input. Because I'm going to need to create a calculation, I need to convert this to an int. So I'm going to what we call cast the entire input into an integer. Remember that parentheses is going to work inside out. So the first thing that's going to happen is, the user is going to be prompted. The keyboard is going to wait for the user's response, which is going to be of the data type string. And then we're going to convert that string to an integer. and that integer value then will be put into this variable. So now that we have the amount of bugs that were collected for the day, let's keep a running total. So bugs collected is equal to bugs collected plus, so whatever was in bugs collected before, add whatever was collected today. And remember that we can do it this way, or I can make a shortcut and just do bugs plus equals, which is doing the same thing. Okay, remember we saw that in a prior video. So each time I go through for 7 times, I'm going to loop through this code, ask the user how many bugs were collected, put that value into the bugs today, and then keep a running total. When I'm finished with this loop, remember that I has been keeping track of how many times it was in this loop. So the first time I went through, I was 0, 2, 1, 2, 3. And remember at the end here, I ended up having a value equal to, in our case, it's going to be equal to the number of times that the iteration ran. In other words, why do I care about that? Well, let's just start simply. What I'm going to do is, now that I've gone through there, let's print out, bugs, let's see, total bugs collected. And then we'll see what our running total is to make sure that's correct. Okay, so the first thing I'm going to do after I'm done with my loop is print out how many bugs were collected so that I know that that part is working, my equation is working. And then out of curiosity, to demonstrate to you a point, I want to see what is the value of I now. When it started the for loop, I was 0, but it iterated 7 times. And so let's see what our ending value is. So let's go ahead and run our code and see how we do. So I'm going to run it and should be able to bring this up. That's kind of low on there, isn't it? Nah, maybe not. Okay, so how many bugs? Let's say day 1 I collected 5, 2, 5, 10, 5, 8, 10. It's keeping asking me. Okay, so let's evaluate our output. So we can see that we were in that loop 7 times. 1, 2, 3, 4, 5, 6, 7. So the for loop generated 7 iterations. It did this 7 times and then exited, just because that's what a for loop does. Each time it went through and it collected the amount of bugs that were collected, and it accumulated them in our bugs collected value variable. And so all of these values were added, kept a running sum, and it printed out 45. And then the next thing that we can see is that our I at the end was 6. Well, why was it 6? Because we started at 0 and we ran 7 times. So 0, 1, 2, 3, 4, 5, 6 is 7 iterations. So I just want you to keep the idea that that's keeping kind of a running sum. So I guess the last part of our program was that we wanted to know what the average was. So in fact, I can just create a calculation here. Print average. It's not average. So I need to print the bugs collected. I'm just creating a calculation here. Print bugs collected divided by, I'm going to put in parentheses, I'm going to explain this in a minute, I plus 1. So what have I done here besides made another big mess? I kind of did a shortcut. So instead of printing a string and the variable, I'm actually, remember everything inside the parentheses gets evaluated first. So I'm asking the code to run this calculation first and print the output of that. So I was 6 because it ends at 6. I actually need this to be 7 because 7 is how many days of the week that were entered. So I want to be able to generate an average by dividing by 7. You could also put 7 in here, but I'm just demonstrating some concepts. So I could either put I plus 1, which will evaluate to 7, and that will be bugs collected divided by 7. That will work. Or you could just put 7 if you want. Again, I'm just demonstrating principles to you. So if we run that, now we should get an average. And I'll just try to put the same numbers in, 2, 5, 10, 5, 8, and 10. And then the number of total bugs collected was 45. And if we divide 45 divided by 7, we in fact get this average of 6.42, blah, 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 blah. We'll learn how to format that later. But hopefully this gives you a concept of how you can use for loops. Could I have done this as a while loop? Absolutely. But then I would have had to keep track of a counter that made sure that I stopped my while loop when I reached 7 days. So this is another way to do that. So to reiterate, a for loop then gives us the ability to, if we have a predetermined number of iterations we know we're going to run, we can use our for loop. And the for loop uses this variable I to keep track of how many iterations were run. So hopefully this gives you an idea, gets you started, and in the next series of videos we'll actually work through some problems from the book, and hopefully you can follow along and we'll see some of these while loops and for loops again in action besides just our little bug collector. So for now, hope that gets you started.